In this video, we're going to be looking at the homework that's in section 2.3. Okay, here's problem number 1. Of the 8th graders at the Paxton School, 9 played basketball, 9 played volleyball, 10 played soccer, 1 played basketball and soccer only, 2 played volleyball and soccer only, 1 played basketball and volleyball only, and 2 played volleyball, basketball, and soccer. And the question is, how many played one or more of the 3 sports? Okay, so the way we're going to do this is to create what we call a Venn diagram. And this Venn diagram is just basically going to be circles that will be intersecting each other. And in this case, we're dealing with 3 different sports, so we need to draw 3 different intersecting circles. Here's one of them. And I'm going to do this in colors. So here's a second one. And here's the third. Now notice how these circles are intersecting. And I'm going to let the green circle be soccer. The red one will be volleyball. And the black one will be basketball. Okay. Now the way we're going to attack this problem is to work backwards. In this case here, we're going to start with the last statement where it says 2 played volleyball, basketball, and soccer. Now what I'm going to do here is place the number in the space where these circles are intersecting. And it's this space right here because this is the intersection of these 3 spaces, these 3 circles right here. So 2 played volleyball, basketball, and soccer. So that 2 is going to go there. And then we're told that 1 played basketball and volleyball only. Okay, so here, this intersection is this. Basketball and volleyball. That's this part right here. So I'm going to put a 1 right there. And then we're told that 2 played volleyball and soccer only. We're looking at this intersection right here of the red and the green. That's this intersection here. So that 2 is going to go there. And then we're told that 1 played basketball and soccer only. So if you look at this intersection right here, basketball and soccer, the black and the green. And we're told that 1 played basketball and soccer, so that 1 goes there. Okay, now we know 10 plays soccer. That's this whole circle right here. We got 2, 2, and 1. We're going to add these numbers together and subtract that from 10. So 2 plus 2 plus 1, that's 5. 5 from this 10 would be 5. So the 5 will represent those who play soccer only. And then we got 9 that played volleyball. That's the circle right here. And notice we got 1, 2, and a 2. Add that, that'll be 5. Subtract the 5 from this 9, that's going to be 4. So only 4 8th graders played volleyball only. And then for basketball, 9 played basketball. That's the circle right here. We got 1 plus 2 plus 1, that's 4. 4 from the 9 will be 5. Okay. So that's how we complete our Venn diagram in this case. Now the question is, how many play 1 or more of the 3 sports? 1 or more. That means we have to add all of these numbers that are in this Venn diagram. So that means we're going to add 5 plus the 1 plus the 4 plus 1 plus 2 plus 2 plus 5. Well, 5 plus 1 is 6, plus 4 is 10, plus 1 is 11, plus 2 is 13, plus 2 is 15, plus 5 is 20. So 28 graders played one or more of these three sports: basketball, volleyball, and soccer. Okay. So this is how you will complete a Venn diagram. Okay, now let's look at number 2. These deals with Cartesian products here. And we're going to let A equals the set A is going to be the elements R, S. B has the elements A, B, C. And you're going to use this information to answer parts A, B, and C. So in this case here, you're going to find out what is A cross B. A cross B. Well, A has these elements, R, S. And you're going to find the Cartesian product with B, which is A, B, C. And to do that, we use ordered pairs. That means the first element is going to be paired with each and every element of the second set. The second element in the first set will be paired with each and every element of that second set. In other words, the first element of the first set is R. It's going to be paired with A. So we have R, comma A. And then the next ordered pair will be R, comma B. The next element will be R, the next ordered pair will be R, comma C. And then S will be paired with each and every element in that set. So in this case here, S is going to be paired with A. S is paired with B. And then S is paired with C. Okay, so this will be the Cartesian product of A and B, or we can say A cross B. So to answer this question right here, you would choose answer A. Okay, part B is what is B cross A. Okay, so here, B cross A, this time, B is ABC. And you're getting the cross product of that with R and S. So now this one's a little bit different. So now, these elements will be each paired with these two elements of the second set. So now, A is going to be paired with R, and A is going to be paired with S. And then B will be paired with these two elements, so that means that B is paired with R, and B is going to be paired with S. And then you have C going to be paired with R, and C paired with S. So it'll end up like this. So it'll be AR, then AS, then BR, then BS, CR, CS. So in this case here, you'll choose answer C. And then part C, what is B cross the empty set? B cross the empty set. Well, B is of course ABC, and the empty set is this. The braces with nothing in it, okay? If you take the cross product of any set with the empty set, you're always going to get the empty set. Okay, and I'll make my empty set symbol a little bit better. Okay, the cross product of the empty set with any set is always going to be the empty set. This is an illustration of multiplying anything times 0, which will give you 0. So here, this will be answer A, the empty set. Okay. All right, and problem number 3. For each of the following, the Cartesian product C cross D is given by the sets listed. You want to find out what C and D are. So now you're given the cross product. Now you're going to work backwards to find out what set C and set D was to begin with. So in this case here, this is part A. C cross D was this: J comma B, J comma C, J comma D, J comma E. So we want to find out what C was and what D was. Okay. To get this, the first element of C had to be paired with the second element, with each and every element in D. Well, notice we only got one element here, and it has to be J. So J was an element of set C. And it was the only element in set C, because if you can see, the first letter in each of those ordered pairs is the same. The second element came from D. B, C, D, and E were in set D. Okay, so in this case, C has the element J, and set D has the elements B, C, D, E. Okay, now let's look at part B. In this case here, C cross D had these elements: 4, 1, 4, 2, 4, 3, 2, 1, 2, 2, 2, 3. And we want to find out what C and D were to start off. Okay, for C, the first element of each of those ordered pairs came from set C. In this case here, the 4 and the 2 came from set C. Because then 4 was paired with 1, 4 was paired with 2, 4 was paired with 3, and then 2 was paired with 1, 2 was paired with 2, and 2 was paired with 3. So 4, 2 are the elements of set C, which means D will have to be 1, 2, 3. That's the second ordered pair, because you got 1, 2, 3 here, and then again 1, 2, 3 here when you paired it with the 4 and the 2 respectively. So D is a set with the elements 1, 2, 3, and C is a set with the elements 4, 2. And part C. C cross D had these elements: 4, 2, 4, 4, 2, 4, 2, 2. So we want to find out what elements belong to C and which elements belong to D. Well, C was crossed with D, so it has to be the first elements here. In this case, 4 and 2. And then D has the elements 2, 4. And of course 4, 2, 4, 2. So we can say also 4, 2 as well. So C and D are the sets with each with the elements 4, 2. And hopefully this will be enough to assist you with the homework problems in section 2.3.